Hello and good morning. My engineering team has designed an airplane hangar to be constructed at the Coolangatta Airport. This hangar will be 15 metres in height, 20 metres in width, and 30 metres in length, with a roof angle of 5 degrees. The dominant opening will be on the 20-metre wide face. Our initial design was tested using 310 UB 40.4 rafters and columns, Z15019 purlins, and custom orb roof sheeting. These, however, will require tests to identify which will sufficiently and safely, as well as economically, hold up the building. And if these initial conditions are to fail, we will test to find the most adequate material that will economically hold it up. Additionally, the structural stability and all types of connections between rafters and other members must be proved safe and secure. I'll now pass it on to my next team member.
Using the property of any title member, for the line load on the rafter is 1.5 kN per meter. Depth load on the roof only consists of the berlin sitting and rafter set weight equal 0.75 kN per meter because it has no other function. For the wind load, the building it belongs to terror category 2 with the wind speed is 57 meters per second. We find out that the design wind ratio for the building is about 2.60 kN per meter square. Consider different wind angle to the building. The most critical wind upward is on the rafter is about 70 kN per meter. When the wind inward is only about 3.8 kN per meter, combined with the line load and depth load. So the design for the wind upward is reduced 16.3 kN per meter.
Hi, my name is Hong. Now I'm going to talk about how we choose the member for the design. For purling, we use Z15019 because through table property, we saw it. We found out that it's completely able to carry its own weight and roof sitting. For column and rafter, at first we used steel 310 UB 40.4, but then we found out that the unit capacity of it is too small compared to the design moment capacity. So we have to increase it into 460 UB 74.6, which produced the moment capacity just above the design moment as shown on status. Further check for shear capacity on column is made to make sure everything is fine. But moreover, we have to put more two fly braces on the rafter so it can make the structure safe under the wind upward. For bracing, consider the wind load. The wind load on the structure on the column is 9.75 kN and make the displacement of the whole structure up to 100 mm, which means 1 meter in horizontal, which is not acceptable at all. So we have to put two bracing, which have the property of 180 UB 22.2 section brace to make sure the displacement is not too big. Actually, it's reduced to 35.7 and meet with the requirement of the displacement. So now my friend Tarna, she will talk about the connection of the structure. Thank you.
Bracing connection. Testing done 180 UB 22.2 section brace, which is fixed by 6 grade 8.8 M20 bolts to a 10 times 150 mm grade 250 steel plate, which welded to a 460 UB 74.6 columns. In apex connection, initially tested on M16 bolts, but failed due to the prying action. In order to satisfy that, M30 bolts is necessary. Testing under full penetration butt welding with E48XX electrodes just failed the N-star requirement. It was analyzed on the best way to solve this problem, and it was decided to add a 75mm stiffener on top and bottom of flange in order to increase the strength of the weld, therefore passing the requirements. Connection of beam. We used the HA300 plate with 10mm thickness with 55mm eccentricity. Using this method, it satisfied the bearing and tearing. It also used 5M20 bolts. For welding, it requires an 8mm SP fillet weld with E45XX electrodes.
My name is Mohammed Al-Nizi. Today I'd like to speak at the conclusion of this part. The building has been designed according to the client specification and is compliant with all relevant Australian standards. The members used to achieve this 460 UB 74.6 for rafters and columns, Z1 51.9 for purlins, and custom or 0.48 for sheeting. Rafter and column connection are fastened by sets of 5 M20 8.8/S high tension. High tension bolts through 10mm thick HA300 plates attached by use of E48XX SP welds. Apex connection is done by a 10mm thick HA300 steel plate connected by 8 grade 8.8 M30 bolts with E48XX electrode for welding with a 75mm stiffener attached to top and bottom the flange. The bracing connection uses a 180 UB 22.2 bracing rod fixed by 6 grade 8.8 bolts to a 20mm thick HA300 plate welded to the column with E41XX electrode FPBW. All members and connection have been tested and will withstand any possible and scenario.